Okay, this video is for Unit 8, Worksheet 3. And for this, we are going to be working with LOL diagrams. And the reason why they're called LOL is because the axes look like an L, and then there's an O, and then there's an L. And like all of our others, we would have been doing pie charts, but now we had to do data tables, and this here is going to be a little bit different setup. So with that, there is going to be room for error, and it's going to be more of what is the trend. So as I go through these, there's going to be what I put, and what you put may be the same or different, but it is more about what is the trend. So the first one is a tumble buggy drives up a ramp. So as we start off, that tumble buggy is all chemical from the battery. And as it starts to go up the ramp, the chemical is going to go down, the gravity is going to go up, and the E-disc goes down. So I started off with 4 chemical, and I ended with 3 gravity and 1 dissipated. Now you could have done 2 gravity, 1 chemical, 1 E-disc, but the thing that we needed to understand is gravity goes up, chemical goes down, and even if you had no dissipated, I could have understood that. That's okay. But the big thing is gravity up, chemical down, and if you have disc goes up. So the next one is a wind-up toy. And it starts off, the wind-up toy that is already wound up is released and walks across the table. So inside that wind-up toy, it's an elastic spring. So it starts off with all elastic. I started with 4. Don't know why I used 4 a lot on all of these for some reason. And as it walks, it's going to lose all of its energy. So it's going to be total E-dis. Now, if you would have had maybe 2 kinetic and 2 dissipated, that's fine. But we needed to show that elastic went down and dissipated went up. Because in the before and the after, it's not actually moving, so we don't have to put in the kinetic. But if you can if you want. Ball drop analysis number 1. The initial is a single ball before being dropped, and the final is the ball right before it strikes the floor. So it's going to start off with all gravity. And after you drop it, as you drop it, gravity goes down, and kinetic goes up. So we started off with all gravity went down to nothing, kinetic went up to all of that energy. Once again, you could have put in E-dis, but it's going to just make your life more complicated, not needed. The next one is when the ball, just after it strikes the floor for the first time, and then the second part is at the top of the bounce. So that ball, when it hits the ground, is 100% elastic. That ball was round, it kind of deforms, and that's all the energy is turned into elastic, and then it springs itself back up. And when it's at the top, it's going to be all gravity. Now, if you wanted to put in E-dis, you can. Underneath it, I had 3 gravity and 1 dissipated. Each time it bounces, it is going to lose some, but that's up to you. Didn't need E-dis. Number 6, or slide 6. Student kicks the air puck on a level classroom floor. So it's going to start off with all kinetic, and it's going to end up with all dissipated. Some of you are going to try making this complicated by putting the energy of the student kicking. If you wanted to make it all chemical, that's up to you. But for the most part, what was being looked at was the kick is the initial, and after all the energy is gone is the final. A Cheeto sitting on an aluminum pan is ignited and burns for 2 minutes. Well, it starts off with all chemical, and it's going to end with some thermal, some heat, and some dissipated. Now, if you think that there's still energy in there to be burned, you could have put in some chemical. That's fine, but we needed to see that chemical went down, thermal and dissipated went up. So if you went from 5 to 1 on chemical or 4 to 1, just as long as chemical goes down, thermal and dissipated goes up. The carts moving on a track and come to a stop. Well, as they move, it's going to be all kinetic because kinetic is moving. And after they come to a stop, all of that has been dissipated. So the kinetic goes down, dissipated goes up. Glow sticks, glowing and slowly running out of energy. It starts off as all chemical. And as the chemical goes down, dissipated goes up. So the chemical goes down and the dissipated goes up. If you said that the chemical was all gone and we were left with just dissipated, that's fine because that tells me then that chemical went down and dissipated went up. The dropper poppers that I failed on. So starting when the popper is in contact with the floor. So it is inverted, so it's all elastic energy. And when it pops, it goes up. Now, as we take a look at this, this here is after it's popped and it's at the very top. Now, instead of that, some of you may have or wanted to split that energy into kinetic and gravity because it's moving and it's gravitational. So the elastic is transferred into kinetic and gravity to the point at which it's all gravity. So those are the LOLs. And once again, it's more about the trend on this. And our quiz over this, over LOLs, will be on Tuesday. And if not Tuesday, it'll be on Monday. And we'll go from there. Otherwise, have a great day.